All right, this is chapter 1.3, use midpoint and distance formulas. We have 2 vocabulary words we're going to cover as well as 2 formulas. The 2 vocabulary words are here, midpoint and segment bisector. Midpoint is the point that divides the segment into 2 congruent segments. So I have line AC here, and I would write that like this. I could also call this line BC, line CB, line CA. Within this line, I have 3 segments actually. Those segments are segment AB, segment AC, and segment BC. And each of those could be written with the letters reversed, but those are the 3 segments that I have. If I do this on my picture, then that means that B is the midpoint. Why? Because it divides segment AC into 2 parts. So this means that AB, segment AB, is congruent to segment BC. So the midpoint that divides the segment into 2 congruent segments. So this is the congruency statement that I would write, and that means that B is the midpoint. So if you see this picture, then you know that B is the midpoint, and also if you see this statement, then you know that B is the midpoint of AC. Also, anytime you see a statement like this, if you don't have a picture, you should draw a picture. Now let's look at segment bisector. Segment bisector is a point, ray, line segment, or plane that intersects the segment at its midpoint. So if I think about my line from before, we know that B is the midpoint. Well, a segment bisector is something that goes through that point. Now notice it could also be just the point. So we could call point B a segment bisector. More often than not, you're going to see the segment bisector as something like this, where you have a line or a ray or a segment that goes through the midpoint, that intersects the midpoint. So I could put a point here and call that D and call this F. So then I would say line DF, assuming there are arrows here, line DF is the segment bisector of segment AC. That is a true statement. I could also say that segment DF is the segment bisector. So a segment can bisect another segment, or I could even make it a ray and I could call it ray BD, for instance. Or I could say ray BF. All of these are segment bisectors. They bisect segment AC. Now let's take a look at the formulas. The first formula we're going to look at is the midpoint formula. This formula is a way to find the midpoint of any segment. Again, remember, we do not find midpoints of a line. So I have this segment RS, and I have given coordinates to these points R and S. I can find the midpoint. We know that the midpoint is going to divide RS into 2 congruent segments. And so the formula for this is going to be x1 plus x2 divided by 2. That will give me the x coordinate of the midpoint. And then y1 plus y2 divided by 2 will give me the y coordinate. So now I'm going to kind of write it like this: the x coordinate of the midpoint and the y coordinate of the midpoint. That's what each of these represent. So I can label either of these points as x1, y1. It's the same as when you're doing the slope formula. So I'm going to call this x1, y1. I'm going to call this x2, y2. So now I'm going to plug this into my formula. So 1 plus 4 divided by 2, and then negative 3 plus 2 divided by 2. That's going to be my coordinates, which is 5 over 2, comma, negative 3 plus 2 is negative 1 over 2. So this is my midpoint, and I could assign a letter to that, and then I could also plot it on my line. Lastly, we're going to look at the distance formula. Now, on a graph, if I have a point here and I have a point here, all I have to do to find the distance between those 2 points is to count 1, 2, 3, 4. So I know that the distance here is 4. Why? Because it's vertical, and I can literally count the spaces. But when I have a point over here, and I'm trying to find the distance between these 2 points, I cannot simply count spaces. And so we are going to use the distance formula, which all the distance formula is Pythagorean theorem. So we're going to review that very quickly. So I could make this into a right triangle, and we know that in a right triangle that this is A, B, and this is C, and we know that A squared plus B squared equals C squared. So I can count A, I can count B, and if I can do that, then I can find C. So A is 1, 2, 3, 4, so 4 squared, plus B is also 4. That is going to equal C squared. So 4 squared is 16, plus 16 is C squared. That's 32 equals C squared. So C is the square root of 32, which I could simplify to be 4 square root of 2. Why? Because 4 squared is 16, and 16 times 2 is 32. So that would be the distance of C. Now, the actual distance formula is not what Pythagorean theorem looks like, but it's essentially what we just did in solving that. So let's look at the distance formula. The distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared, and that's all under the radical. So what does all of this mean? This x2 minus x1, that is b, and then we squared it. This y2 minus y1 is a. This is b squared plus a squared, and then we take the square root, which is exactly what we did here. We had a squared plus b squared, or b squared plus a squared, it's the same thing. But then what was our last step? Our last step was to take the square root of that. And so the distance formula comes from Pythagorean theorem. So if you ever get stuck remembering what the distance formula is, you can actually just use Pythagorean theorem instead. All right, so now we're going to actually use the distance formula. So it says given segment RS with coordinates r, 2, 3, and s, 4, -1. Find RS. Now remember, this means the distance of RS. So notice it doesn't have the line on top. So that means distance. So let's remember our formula. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared, all under the radical. So now we're going to plug in our values. So the square root of x2 is 4 minus 2, and that quantity is squared, plus -1 minus 3, and that quantity is squared. So 4 minus 2 is 2, so this is 2 squared, plus -1 minus 3 is -4 squared, which looks like this, -4 squared. So this is the square root of 4 plus 16. Why? Because when I square a negative number, negative times a negative is a positive. So that comes out to be the square root of 20, which is the same as 2 square root of 5. Because I can factor out a 4 from 20, and the square root of 4 is 2. Be careful and remember that if you are subtracting a negative, that turns into 3 plus 8. 3 minus -8. If you're subtracting a negative, remember subtraction means go left, negative means the opposite of. So left, the opposite of, is actually right. So you're actually just adding. So be careful with that.